A computer chip under heavy load generates an intense amount of thermal energy. Tracking that heat is a necessary defense to keep processors from slowing themselves down, sustaining permanent physical damage, or suddenly shutting off. For a single machine, lightweight software utilities like HWMonitor handle this job perfectly. They pull direct readings from local sensors to give you the exact numbers: current core temperature, fan speed, voltage levels, and clock speed. If you are managing a personal computer, a gaming workstation, or a standalone test rig, those basic hardware metrics give you everything you need to keep the system safe. But take that single machine and multiply it by 10,000 inside an enterprise data center, and the rules change. In that sprawling, high-density environment, a sudden 5-degree temperature spike points to a systemic physical disruption rather than a harmless numerical quirk. That excess heat indicates failing internal fans, blocked cooling paths choking airflow, or tightly packed hardware racks. Left unchecked, the hardware distress rapidly cascades into digital failures. It compromises active virtual machines, stalls database queries, and paralyzes customer-facing applications. At the enterprise scale, localized heat acts as a direct threat to overall business service availability. And with thousands of servers in play, it is a threat you cannot neutralize with manual, machine-by-machine inspection. This is where basic monitoring tools start to fracture. First, many are designed around a single vendor, leaving severe blind spots in mixed environments that rack Dell, HP, Cisco, and Huawei hardware side by side. But their most critical vulnerability is structural. Standard utilities rely entirely on the server's operating system to collect and transmit their data. When a processor overheats severely, the hardware's immediate self-preservation response is often to lock up or completely freeze the operating system to prevent further damage. As we can see in this flowchart, when a temperature sensor attempts to pass data through that newly frozen operating system, it hits a dead end, resulting in a completely blank output screen. Because they are tied to the OS, these standard monitors go completely blind, exactly at the moment the IT operations team needs them most. Sensaka is an enterprise platform engineered specifically to eliminate these blind spots during hardware failures. It achieves this by utilizing a different architectural approach called out-of-band monitoring. This connects directly to the server's baseboard management controller, or BMC chip. This diagram compares methods. Traditional in-band monitoring routes traffic through the operating system. Out-of-band monitoring uses a separate management network routing directly to the BMC component. This independent connection lets Sensaka track temperature, pull logs, and execute remote restarts, even when the OS goes down. By decoupling the hardware sensors from the operating system, Sensaka guarantees continuous visibility and control, regardless of whether the server's software is healthy or completely frozen. With that constant stream of data secured, Sensaka wraps those raw temperature metrics in physical context. It tracks the rising heat against the exact rack location, the condition of local power supplies, and ambient room humidity. Taking that a step further, the platform maps those localized hardware risks directly to the business services that depend on them. In this dependency tree map, we start with a single overheating server node at the bottom, which traces up through the network and storage layers, revealing a direct impact on the customer checkout application. This creates a stark operational contrast. A basic alert states that server 4 has hit 95 degrees Celsius. Sensaka, however, generates a highly specific, actionable narrative. It alerts the operations team that the customer database is actively at risk due to a failing fan on server 4. It provides the physical rack coordinates and automatically triggers an IT service management workflow to dispatch a technician. A basic utility tells you what a machine is doing only while it is healthy and reachable. Sensaka pinpoints the operational risk, identifies the threatened business service, and empowers IT teams to resolve the hardware failure before a single end user experiences downtime.